when solving quadratic inequalities, the idea is that you get the entire quadratic all on one side completely factored, as in this first example. Then it's very important to go ahead and find your x values. So we're going to set each one of these factors equal to 0 and solve them for x. These values are known as critical points. And these critical points will set on the number line, and they'll break our number line up into different sections. I like to put little dotted lines, kind of making it more visual there as far as how it separates up the sections. Now we're going to pick region points to test our inequality with here to determine where the solutions are. And these are called region points. We're going to pick one point in each region. So I'll pick a -3. And remember, this is the number line, so there is a 0 here. Everything to the left is negative. Everything to the right is positive. Between -2 and 3, I'm going to pick the number 0. And to the right, I'll pick the number 4. Remember, any number in those regions will work, but certainly the smaller the better if we're calculating anything. Now, I'll go ahead and test the points. I'm going to put the -3 in, the -2, 0, 3, and 4. Now, all we need is to determine whether it's positive or negative in that region to let us, well, we have to determine whether it's going to be a true or a false statement there in order to determine where we shade. Let's go ahead and plug the -3 in. And remember, just like in class, we do plug these in to our original equation up here, or into our factored form, so that we end up with a -3 in for x is going to make it -3 minus 3, that's a -6. -3 plus 2, that's a -1, which is a +6 greater than 0. +6 is greater than 0. Is that a true or a false statement? That is true. So this region point, because he is true, is shaded. Now remember, with critical points, we're either going to leave an open circle or a solid circle, depending on whether it's true or false. Let's test our first critical point. When we stick the -2 in for x, we have -2 minus 3, that's -5. -2 plus 2, that's 0. Is 0 greater than 0? True or false? That is a false statement. It would be true if there was an equality involved, but because it doesn't have the equality on there, this is not a true statement, it's false. And because it is false, we're going to give him an open circle. Solid circle would mean that he is actually part of the solution, and open circle means no, you're not. Okay, let's test the 0. If I put 0 in, we get 0 minus 3 or -3. 0 plus 2 is +2. That's -6. Is -6 greater than 0? That is false. So we crossed him out. Because we're not going to shade that region point, we go ahead and cross out the 0. That way, we know we've already tested that point and we're on to the next one. Let's try the 3. 3 minus 3 is 0. 3 plus 2 is 5. Again, same problem we ran across with the -2. This is a critical point, so we know that we're either going to give it a solid or an open circle. Because it gives us a false statement here, 0 cannot be greater than 0. We're going to go ahead and give him an open circle. Let's test the last region point, 4. 4 minus 3 is 1. 4 plus 2 is 6. Is 6 greater than 0? Well, that is a true statement, isn't it? So we shade that region. Now remember, all of our answers are still going to be required in interval notation like they were on our linear inequality section. So again, as you're reading it from left to right, the shaded area starts from -infinity to -2. Parentheses, because of the open circles, those same rules still apply. If you need to review the linear inequality section where I do describe all of the notation that is involved with inequalities. It starts back up again at 3 with a parentheses because of the open circle out to infinity. Let's go ahead and take a peek at a second example. On this second example, they actually don't factor it for us. We have to do some of the work. So let's see, we make sure everything is on the left-hand side. Now we're going to factor it completely. X minus 2 and x minus 2. I'm going to solve each one of those for the x value or our critical points. Now, because they're exactly the same factor, 2 is it. We don't have anything else. So I'm going to put that single critical point on my number line, break it up into regions, which helps me to visualize and find my my region points. If I'm picking a point to the left of 2, I'm going to pick 0. 1 is available, even all of the negatives, but 0 is really easy to plug in, so I encourage you to do that. A number to the right of 2 would be 3. Now I'm going to go ahead and test my points. 0, 2, and 3 are the points we're testing. So if we plug a 0 in here, it's going to be 0 minus 2, that's negative 2, and 0 minus 2, that's negative 2. Is 4 greater than or equal to 0? All I'm doing is plugging into this equation here. True or false? That one is true. Let's test our 2 now. Remember, because 2 is a critical point, he's actually on the number line, we're going to give him an open or a closed circle. When we plug 2 in, we get 0. And 2 minus 2 again is 0. That's 0, and is 0 greater than or equal to himself? That is also a true statement. So on this one, we'll give ourselves a nice solid circle on that critical point. Let's test the 3. When you plug 3 in here, we're going to end up with 1. And 3 minus 2 is 1 again, which gives me a product of 1. Is 1 greater than or equal to 0? True or false? That one is also true. Now, this one's kind of interesting. Don't always assume that you're going to get the 2 kinds of graphs that we did here. It's very possible to one side have one open or have the entire thing shaded from our previous example. Let's go ahead and write the solution out for this one. Remember, it's the shaded region as it goes from left to right. It starts at negative infinity, and it never stops being shaded, but it does continue all the way out to positive infinity.